Good day, everyone. Welcome to the fifth lecture of this class entitled Test of Relationship. I am Dr. Nico Lawrence Midowsin, the course instructor of this class. In this session, we will talk about the word correlation. When you say correlation, it means that association, not causation. It means, for example, you have variables X and Y. You are measuring the intensity or magnitude of their relationship, how X is related to Y. It's not causation in such a way that X determines Y. It's not that. In correlation, you only describe the intensity or the magnitude of their relationship, how related they are, how associated they are, but not how X determines Y. That's not correlation, it's causation. The statistical test that uses correlations are as follows. You have Pearson R, which can be used if you are dealing with interval ratio data. It could be interval ratio, or ratio data. For Spearman rank, is used if you have ordinal data. And chi-square test of independence if you have nominal data. Let's start first with the Pearson R. The complete name of Pearson R is Pearson Product Moment Correlational Coefficient, or simply Pearson R. Is composed of this long formula. You have summation of xy minus summation of x times summation of y all over square root of n summation of x squared minus summation of x in squared and summation n times summation of y squared minus summation of y in squared. So you need to have several columns that you need to prepare in order for you to input the data that you need if you will be doing manual computation. But again, in this class, we will be using digital computation using Microsoft Excel data analysis. So for example, you want to correlate the hours of sleep and test scores. We know hours of sleep is in ratio data, while test scores are interval data. So based on the combination of the two variables, we have to use Pearson R correlation. Okay. So if you are solving this kind of Pearson R problem, I'd like you to see the given example. The relationship between stock A and stock B. This column contains the product of x and y. This column is x squared and this column is y squared. Following the given formula here, you just have to substitute the value. You will come up with this answer. That is negative 9.9088. So the value of the Pearson R, or Spearman rank, ranges from -1 to +1. If it is located in the negative side, therefore they are exhibiting inverse proportion, or they are inversely proportional. It means that if x increases, y decreases, or if y increases, x decreases. So that is the interpretation if you got a negative value. Now, the distance from 0 to 1 or 0 to -1 determines how intensive or how far or how close the relationships in terms of the interpretation. Okay. Now, to interpret the value of Pearson R, here is a provided table. Interpretation of R values. If R is equal to +1, or -1, it is a perfect positive or negative rectilinear correlation. For example, you got -1. It is positive, perfect negative rectilinear correlation. If you got +1, perfect positive rectilinear correlation. We're just choosing among the two options. From 9 to 1, that is very high, positive or negative. So it could be negative zero point 0.9 or negative 1. Negative 8 to negative 9, something like that, or positive zero point 0.8 and positive zero point 0.9, that is high positive. While zero point 0.4 and zero point 0.6, that is moderate positive or negative. Zero point 0.2 to zero point 0.4, low positive negative rectilinear correlation. And 0 to zero point 0.2, that is negligible positive or negative rectilinear correlation. And if you got the value of 0, therefore there is no significant relationship between the two variables. Is that clear to everybody? Okay, let's proceed. This is how you will interpret the data if they are plotted using particular software. The four figure symbolizes the correlational Pearson correlation coefficient. So the given number one, you can see here, large positive correlation, because as X increases, Y also increases. And also you can see here large positive because the graph can be plotted almost in a linear equation. Second one, you have the medium positive correlation. You also seeing here that uh, above that age still uh, increasing. So if you increase that, another variable also increases. The number three, small negative correlation. It is negative because it starts from the negative side to the positive side. Well, this one, the scores are somehow is really random. That's why you call it as weak or no correlation. Is that clear to everybody? Okay, let's proceed. Okay, what about this table? You can see here the cross section in between the following variables and the variable. So high school hours spent studying. When you combine them, you got one. You got one because you compare them on their own data set. Okay, example, exam score and exam score. You correlate, then you will also get one because you determine them using their own value. IQ score you got IQ score and IQ score you also get one because you compare IQ score to its IQ score. So therefore, you can see the changes in the other is also available in changes in the other variables. Okay? So for example, this one, you have to compare hours spent studying and exam hour. You got 0.82. Okay, so it means to say if you are studying more, uh, it is exhibited in your exam that your score is high. Okay, IQ score and exam score 0.33, hours spent studying, and the rest. Okay, so I want you to use this table in interpreting your results so that you know how to interpret results. And what about data coming from the SPSS? Well, the data is coming from the SPSS, same with Excel. You just have to cross the what is in the row and what is in the column. So height and height, you get one. Kasi you only correlate the variable on its own value. While height and weight, you can see here 0.513. That is the value of the Pearson R, while the significance is 0.00. Therefore, you can see there is a high correlation exists between height and weight. Same as the given variable here. Okay? Another example, the age of a person and the amount of cholesterol in their bloodstream. So you can see here as the age increases, accumulation of cholesterol is also observable. You got 0.882 here, which means that is 0.882 within here. So there is high positive rectilinear correlation. Okay, if it's negative, we choose between the two, negative or positive. Okay, so you still get 0.882 here for the Pearson R. Their p-value is 0.001, 0.001. Therefore, their p-value is equal to 99.9% sure that their result is valid. Okay. Another test that you will encounter also is a Spearman rank. I will not dwell so much time here because they can also be applied using Excel. That is used to determine the correlation coefficient between two ordinal variables. Two ordinal variables. Same as Pearson rho. It ranges from +1 to -1. In terms of interpretation, also the same. Okay, you just have to click via SPSS that you are tallying data, so they will be able to suggest what kind of specific treatment you can use to justify your results. Another formula you have here the chi-square, which you can use if your data are both in nominal. Again, nominal, this is the formula, okay, for chi-square. So ordinal is Spearman rank, interval ratio, Pearson R. Okay, you can see here, dito lang tayo titingin. That's 0.205, 0.200, 0.239. Okay, let's continue here. The solving of a relationship or correlation using Evans Excel data analysis. So I have two sets of data comparing the income, expenses, and savings within their group or among their group, and also the comparison between the number of online shopping and income of the customer. So can we say that the higher income, there will be more number of online shopping? Okay. Okay, we will be following the same uh, procedure. We will start here first. Okay, so two variables muna. So data analysis, you click that. Then you choose correlation, and then okay. And this time, okay. Oh, sorry. There's a mistake. So data analysis, correlation, okay. And then you highlight the data that you want to know the relationship. So I want to know the number of shopping online and income of the clients. Okay. Then click OK. Like what I have mentioned a while ago, you can now see that uh, this is the cross section or the corner of the column 1 and column 2. Column 1 is the number of shopping or income of the client. So you can see here the relationship. So that is the one that we are, looking for. So 0.59663. So we just have to reduce the number of decimal. We have 0.596. So to interpret that, allow me to share uh, this table. So you can see here that the range 0.596 is somehow here. So that is moderate positive rectilinear correlation. So between the students, uh, between rather, sorry, between the number of online shopping and income, you can see that there is a moderate positive correlation between the two. Okay, let's try another so we can master it. Again, data analysis. Again, you are only allowed to highlight two sets of data at a time or a pair of data at a time. You're not allowed to process massive data. Okay, so click correlation again. Okay, and then let's compare the relationship exists between income and expenses. Then click OK. So you can see here, the correct value for that is 0.936986. This one. Okay. So let's interpret that. 0.9369, that here it is. Okay, that is very high positive or negative rectilinear correlation. So it means that as the income of the employee increases, also the expenses increases. Okay, so I'd like you to work on the other one. Let's try the expenses and savings. Okay, expenses and savings. Then, okay. So you can see here, the value is 0.14. Ayan. So 0.141. So it means if you're going to examine that, the 0.141 is under uh, the answer is 0.141. So along here, so it could be negligible, positive, or negative rectilinear correlation. So it means that the expenses and income have negligible, positive correlation. Okay. So with that, let's first with the following information. That's all for today, and thank you very much for listening. Please work on your tasks uploaded in the LMS or Google Classroom. The deadline of that would be on Monday. Monday. So on Tuesday, we could have your uh, summative exam already. Okay, that's all, and goodbye, everyone.